All right, lesson 4.1, applying the triangle sum property. Okay, so chapter 4 is all about congruent triangles. You already defined these words. I just want to go over them for a second. Everyone knows a triangle is a three-sided figure. Equilateral triangles has three congruent sides. You use those hash mark notations. And then an isosceles triangle has at least two congruent sides. Scalene, no congruent sides. This is all nothing new here, okay? Equiangular, here's a little something, might be new. It has three congruent angles and they always measure to 60 degrees each. A acute triangle has three acute angles, all less than 90. A right triangle has one right angle. An obtuse triangle has one obtuse angle, which is greater than 90. And a corollary is something that can be proven using a theorem or definition. All right, that's just a little quick over the vocab, all right? So in the front of your worksheet, but you may or may not have it, or maybe take notes, okay? We're gonna classify the triangles by their sides and their angles. So try your best to copy these down if you're using a notebook. But each one of them I have labeled sides, angles, because I'm gonna classify the triangle by its sides and then by its angle. So this triangle has two congruent sides. It also has a right angle, so it's a right isosceles triangle. This triangle has no congruent sides. There's no hash marks to indicate that any side is equal to the other. So it is scalene, and there's an obtuse angle, so that makes it obtuse for the angles. Here is an isosceles triangle again, and it is acute because all of the angles measure less than 90. This is an equilateral triangle, but I forgot some notation, so I apologize for that. There we go. Now all three sides are congruent. All equilateral triangles are also equiangular to classify it by its angles. You could say it's acute because all of those angles are less than 90, but either one would be fine. Here is a triangle that all three sides are given. None of them are the same, so it is scalene. It has a right angle, so the angles, it's right. Just classifying triangles by their sides and by their angles. All right, next. Okay, so this might look completely overwhelming, and let me fix it for you for a second here. First, if you thought that we were going to be done with the distance formula, you were wrong. So hopefully you didn't forget how to use that. Just want to cover some stuff up. Okay, so there. Let me get this out of the way. First, we're going to classify this triangle PQR by its sides. So you need to graph these points on the coordinate plane. I have done so on my coordinate plane here. P, -1, 2, Q, 6, 3, and R, 0, 0. So in order to classify it by its sides, we have to find the length of all three sides. This is the distance formula in case you forgot. That's how we're going to find the length. So first, that's funny. I did not know what I wanted to do. Now this one's in my way. Okay, so we're going to find PQ. I'm going to plug those points in and just work it down and solve it. Right, and I get down to square root of 50, which breaks down into 5 root 2. So I'm going to go ahead and write that on PQ. 5 root 2. Right, we're checking the length of all three sides to see if any two sides are congruent. So let's find the length of RQ. This length right here. They look like they could be the same size. So you just work it down. 6 minus 0 squared, that's 36. 3 minus 0 squared is 9. Add them together, 45. Break it down, 3 root 5. Well, it is not the same as PQ. Now this is, oh no. 3 root 5. We do have to check the length of PR because even though visually we know that it's not the same size, but we just have to complete the equation and be sure, because maybe it's playing a trick on us. All right, so we find PR. This one's really easy. I get the square root of 5. So no two sides are the same. So this is the square root of 5. So this triangle, we classify it by its sides, is scalene. I keep wanting to do that. All right, so since no sides are equal, this is a scalene triangle. Back to the top, because then there was another question that said, then determine, is it a right triangle? We are looking for perpendicular lines, right? Reciprocal opposite slopes. So now we have to take the slope of all three sides. After this, we're all going to be geniuses with slope, okay? So remember the slope formula. These are our 3 points. First, I'm going to find the slope of PQ. Plug it in. The only reason it's addition here is because it's 6 minus -1. I just skipped a step, unlike I did over here. This took a lot of time to put all this down on here, just so you know. Then we find the slope of RQ, which is 1/2. These are not perpendicular to each other, so I do not have a right triangle just yet. Keep on going. We find the slope of PR, which is -2. -2 and RQ are reciprocal opposites of each other. If we multiply them together, it's going to equal -1. So this is a right triangle. Right here at RQ, PR, there's a right angle. RQ and PR, so right here we have a right triangle, so you can put the little mark. Perfect, so now it's a right scalene or scaling right triangle. All right, so that's that. Don't forget how to use the distance formula and the slope. All right, next is the super important rule, the triangle sum theorem. I'm really not concerned about what theorem number it is, but the triangle sum theorem states that no matter what triangle you have, small, big, doesn't matter, obtuse, right, acute, the interior sum will always equal 180 degrees. So here I have a right triangle. Remember, this is 90 degrees. So 90, or x plus 52 plus 90 all equals 180. Or if you want to take 180 and subtract your other two angles, you will find x. So this is 38 degrees here. Here I have an isosceles triangle. In isosceles triangles, the base angles are always congruent. We'll talk about that later. But so 2x plus 30 equals 180. 2x equals 175. X equals 75. So the measure of those angles is 75 degrees. Oh, oh no. All right, I guess I could put 38 in here too. All right, and here I have an obtuse angle in the bottom. Same thing goes. The interior sum is 180 degrees. X plus 20 plus 120 equals 180. X equals 40 degrees. Okay, interior sum of any triangle is 180 degrees. All right, now we're going to talk about the exterior angle theorem. What that means is, well, we can read the definition. The measure of an exterior angle of a triangle is equal to the sum of the measure of the two non-adjacent interior angles. Remember, non-adjacent, the two angles that are not next to this exterior angle, okay? This is the exterior angle. Right? This angle C is the adjacent angle, right? Remember, to be adjacent, you're like, that's my neighbor. So you don't want to use this unless it's given. The adjacent angle will form a linear pair, right? So together they'll equal 180, you know, if you need to use that to find the exterior angle, but that's not what we're talking about. I just want you to know, if you're given the two non-adjacent angles, you add those together, that is the same as the sum of this exterior angle. Which is pretty cool. All right, so sometimes they're given to you in expressions, right? This exterior angle is 2x plus 10. So I simply add the two non-adjacent angles together. I made my equation right here. X plus 65 equals 2x plus 10. Solve for x. X equals 55. If I plug that in here, right, this is 55 degrees. 55 plus 65 is 120, right? So this exterior angle is 120 degrees. All right, that's your fun facts. Interior sum, always 180. Exterior angle theorem says you take the two non-adjacent angles, add them together, and set it equal to that. And you will be good to go. All right, here's a corollary, just like, hey, you already know about the triangle sum theorem. Here's a little something, something. You can also know about right triangles. Okay, so only in a right triangle, because we know this is 90, the other two remaining angles are complementary, right? That means they equal 90. So you can still use 180 if you want and use this 90 degrees, or if you already know it's a right triangle, the other two angles are complementary. Add them together, set it equal to 90, boom, solve for x, plug it back in. Here's 38 degrees, 54 degrees. I add these all up and I still get 180 degrees. All right, so here's your assignment. The reason why I want you to draw pictures for 32 to 37 is because you're going to have ulterior, or alternate interior angles, corresponding angles, linear pairs, angle relationships, and it helps you see it better sometimes when you write it down. Plus, I don't want you drawing in the book. All right, so get this done. If you have any questions, let me know. All right, bye.